This is the review for 7A. The two targets or success criteria in 7A are finding different angles on the unit circle and estimating their coordinates, and to determine the sine, cosine, and tangent for an angle in standard position. The first thing I would like to do is to remind you of our unit circle. When we're dealing with our unit circle, we need to remember that the coordinates over here, if I'm at this point, this is where we start with our rotation counterclockwise around the unit circle. The coordinates here are 1, 0. The coordinates up here are 0, 1. To the left, we have -1, 0. And down here at the bottom, we have 0, -1. This will become very important as we try to determine sine, cosine, and tangent at some of our standard positions around the unit circle. So here's a nice unit circle with some dots on it. For any point on the unit circle, we can define it using just one key feature, the angle measure. So please remember, the measure of the angle is equal to the measure of the arc. So as I look at these dots on the unit circle, this angle goes over to here, whatever theta is, so this rotation counterclockwise around the circle is also equal to theta. Using some of the angles that we have been working with, if this is pi over 12, and about halfway would be where we'd have a quarter pi. So this one's a little more than halfway, so this probably is one of our thirds. So this would be like pi over 3. And remember, things reflect, so this point here appears to be in the same position as this one on the other side. So if this is 1/3, this would be 2/3 pi. And then, of course, as we go down, this would be where pi is. Remember, it's always halfway around the circle is pi. And if we watch and look at the reflection, this one goes down to here. So this would be 1/3, 2/3, here's 3/3, and of course here would be 4/3 pi. And if you follow that over to there, this would be 5/3 pi. And when you complete the circle, then of course we are back over here at 2 pi. So where we started was 0 and we ended at 2 pi. 2 pi is also 6 pi over 3, because 6 divided by 3 does give us 2. Some of these other dots that I didn't put coordinates on might be some of our pi over 6s, could be a pi over 12 depending on where they're at. But what you need to keep in mind is that the pi over 3 is going to be farther up than halfway in this first quadrant, because 1/3 is a bigger chunk than 1/4. 1/6 would have been about right in here, so that might have been pi over 6. And again, you could play going around the circle in 6ths. The next item I want to make you recall is that at each of these coordinates, the x value is cosine and the y value is sine. So if I know the coordinates of this point, which seems to be here at 7 pi over 4 because it's halfway. Let me move that x because it seems to be kind of in the middle of my fraction. So this is x, that's y. If that's 7 pi over 4, that's the point at which we get an isosceles right triangle. An isosceles right triangle. So that would be the point at which these two would be equal. In other words, if this is x, so's this, and this is our hypotenuse, which is 1. So we know that x squared plus x squared has to equal 1. So we have the idea here that we have 2x squareds. So x squared is equal to 1/2. And then we would take the square root. So x is equal to the square root of 1/2. Well, the square root of 1/2 is approximately 0.71. If you pick up your calculator and you take the square root of 0.5 or 1/2, you should get about 0.71. And it is a plus or minus situation because you did do a square root of x squared. To determine this point then, the coordinates of this point, I know that it's 0.7, 0.7, and you could go 0.71 if you'd like to. And then the next thing I need to think about is direction, as far as this is positive, but this one's negative. So that would be a positive 0.7 and this would be a negative 0.71. If I was up here in the first quadrant, they'd both be positive. In the second quadrant over here, because my x's are negative, this point here, which is 3 pi over 4, this was pi over 4. 3 pi over 4 would give me a negative x value and a positive y value. And then down here in the fourth quadrant, if you come down in the middle, that's where 5 pi over 4 lives. And that would have the coordinates of negative 0.71, negative 0.71, because in the third quadrant, both your x and your y values are negative. So once you know one point on the unit circle, you know 3 others. Automatically, you just know to change those signs to match the coordinates, because in the first quadrant, everybody's positive. Everybody's positive. In the second, the x is negative and the y is positive. In the third quadrant, both of them are negative. In the fourth quadrant, x is positive, y is negative. And that's always true, whether you're dealing on the coordinate plane or the unit circle, that will be true. Okay? All right, next idea. Kind of the same thing, being able to label points, knowing where things are on that unit circle. What is the measure? And this does go from your workbook. We're on page 26 of Unit 6, Part 1 of 2 workbooks. What is the measure of the angle of POR? Well, POR is this angle, and that goes along with this arc. So we have our right angle and our arc. Well, remember from the beginning, if this is 0, it's also 2 pi. That halfway around the circle is pi. So we're talking about half of pi. So that's why this point up here is pi over 2. So the measure of this angle is the same as the measure of the arc. So this angle POR would be pi over 2. Here halfway in between at POQ, well, what's half of a half? And sometimes I think of money, if pi is a full dollar and pi over 2 is 50 cents, what's half of 50 cents? Well, a quarter. And that's true. That's going to have an angle of pi over 4. So that point right there would be pi over 4. Label the point U on the circle that has a measure of POU is 3 pi over 4. So POU, if this is 1/4, a half is 2/4, then we need to go to 3/4. So this would be where U would be located at 3 pi over 4. It's 3/4 of the way counterclockwise around the circle. The whole circle is 2 pi. That's the circumference of our circle. So halfway is pi, and we're halfway in between a half and a whole, so 3/4. Okay, this last one, 3 pi over 2. That's like saying I want 1 1/2. 3 halves is 1 1/2 pi. So I want to go 1 pi plus a half a pi more. So we would be down here. 1 pi plus a half a pi more. And that would be where we would put point V. So you should be familiar with all these places on the unit circle. You should also realize that this point over here would be 5 pi over 4. And halfway over here would be your 7 pi over 4. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4 to get around the unit circle. Okay. So this is where we're talking about a coordinate. We know that C here is at 0.5, 0.87. That is our point C. So once we know C is there, then it's symmetrical across the circle. So point D would be in the second quadrant, so it would have negative x's, but still a positive y. Now from that, I realize this question doesn't ask this, but the one on the quiz will. From that point, then I should be able to determine the sine, cosine, and tangent of both point C and point D. So let's do point C first, the sine at point C, so of, let's call this angle ABC, or we could call it pi over 3, so let's just use the radian measure. So the sine of pi over 3 is going to equal the y-coordinate, because remember from that slide previously, the y-coordinate is the sine, so 0.87. The cosine of pi over 3, that would be the x, 0.5, where the tangent of pi over 3, that's going to be y over x. So tangent of theta is always going to be sine divided by cosine. So it's always the y value divided by the x value. Tangent is like slope, y over x. So I would have 0.87 over 0.5. And you can choose to decimalize that out, or you can leave it as that fraction. Most of your teachers will be fine with you leaving it as the fraction value there. Okay, so here in question A, then they ask where D is, which is what I told you up there. And then finally in this question, they want to know where E is. And if you check symmetrically, it would be reflected over. So E would be at 0.5, negative 0.87. And that would imply that the sine of 5 pi over 3 would equal negative 0.87, and the cosine of 5 pi over 3 would equal the x value of positive 0.5, and the tangent of 5 pi over 3 would equal the y value, negative 0.87 over the x value of 0.5. Okay. The last thing I want to make sure I talk about in this video are these random ones. Basically the same thing as what I was showing you on the slide, so you just have to realize that, okay, I need to draw myself a unit little circle over here and think about where I'm at on that circle. Oh, that was not a good circle, but it'll do. 0 and 2 pi. We know that pi over 2 is at the top. We know over here is pi. We should know that 3 pi over 2 is going to be at the bottom. Then we think about our coordinates. So my coordinate for over here is 1, 0. Up here, I'm at 0, positive 1. Over here, we're at negative 1, 0. And down at the bottom, we're at 0, negative 1. So these two we'll come back to. Let's look at B for a second. 3 pi over 2. 3 pi over 2 is straight down here. They want sine. That means they want the y. So immediately I would put negative 1. On the quarters. The quarters. Those were the ones we were just talking about. So this is pi over 4, 1/4, 2/4, 3/4, 4/4. Down here would be 5/4 pi. So at 5/4 pi, the sine and the cosine are the same. You don't even really have to remember that they're the 0.7s, the 0.7s. They're both negative. So you have negative over negative. That would give me a positive 1. Likewise, over here at 7 pi over 4, that one's going to be a little more complicated. You're going to have to remember that it's the x is positive and the y is negative. So that would give